ratio, what do you think of? Nothing. Okay. Does anyone think, when I say the word ratio, what do you guys think of? Say again? Mixing? Okay, good. All right. So like cooking, you think of like you can use ratios and such for cooking. So if just the word ratio, what does that mathematically mean to you? What kind of number would be a ratio? Yes? 1 to 1, sure. If it took 1 egg for 1 batch of muffins or whatever, that'd be a 1 to 1, right? If there are equal numbers of red marbles to white marbles, it'd be a 1 to 1 ratio. You guys with me? Okay. So the word ratio, what you might think of is like a fraction. Because a fraction is defined to be a ratio of 2 whole numbers, right? Where the bottom's not 0. My camera apparently came to class drunk. Okay, stop. There we go. But a ratio, how can you write a ratio? One way, obviously, would probably be a freaking fraction, like I just said. That would be a good guess, right? Does anyone know a different way to write a ratio? Yeah, cool. So if I had, if I went to the, let's see, if I had 11 white marbles, you could do it, Jeff. Oh my God, forgot how to write over the break. Okay. And you're all like, you never knew how. And I had 15 red marbles. So I could ask, what's the ratio of white marbles to red marbles? So you could either say it as a phrase, 11 to 15, white to red. You could say it like you just did. You could write it 11 colon 15. So then it looks more like a time, but all too bad. Right? Or you could write it as a fraction, 11. Now, the thing about the fractional form of it, what does the bottom of a fraction, for the most part, what does it normally mean? Out of something? Sure. So the bottom, yeah, there it is. The bottom normally represents the entire amount, correct? If I had 3 people out of 50 that were left-handed, that'd be 3 divided by 50. That'd be 3 over 50, right? How many total marbles are there? 26. So this is a valid ratio, but it's not really exactly the kind of fraction we would make, right? This is what is known as a part-to-part ratio, right? A part of the marbles are white and a part of the marbles are red. So 11 to 15 is part-to-part. Okay, lock it. So this is what's known as part-to-part ratio. So if I did a part-to-whole ratio, I'd have to be specific. So what if I said red to whole? What would the ratio be then? Yeah, 15 red to 26 marble. So you could do 15 to 26. You could do 15 to 26. You could do 15 to 26. Woohoo! Okay, so this represents the fractional part of the whole that is red. Whereas this is not invalid, it just doesn't represent that. It's a different usage of a fraction. Now real quick, if for some reason I was working for some insane person and they said, okay, in this jar, I must have 11 white marbles to every 15 red marbles. And somebody came in and they added 11 more white marbles, right, to try to get me fired because I'm in charge of these damn marbles. That's my job. What a crazy job. Is this guy going to be happy when he comes and looks at his jar? Is everybody with me? So currently it's 11 white, 15 red. He's like, it must be 11 to 15. Somebody comes along and adds 11 white marbles. Instead of me trying to pick out all the 11, what else could I do?
15 red.
Add 15 red. right? Then it would still be in the proportion, don't say proportion, it would still be in the ratio 11 to 15. Right here, wouldn't that just be increasing this to 22 to 30? So if there are 22 white marbles, there needs to be 30 red marbles so the ratio stays the same. Or is everybody with me? So this is basically old math notation used in a slightly different way, right? Up until now, we've been thinking about fractions as out of whole, but they don't have to be. They could actually represent something a little bit different. Okay, all right. Now, of course, over here, if I double the top and bottom, I'll get 30 to 52, and what does that represent? 30 to 52, what do those numbers represent? 52 total. And of course, here there would be 52 total marbles. I like it. Okay, good. So there's a connection between what we normally think of as fractions and what we actually look at as ratios. They don't mean exactly the same thing, okay, especially if it's part to part. All right, so that's basic stuff right there, okay. I kind of said a word really quickly there a minute ago that was a little too soon to say, but let me say it again. If I say the word proportion, how does that relate? Does anyone know what the word proportion means? Me and my squeaky shoes.
Size, right?
Say again?
Size?
Okay, it could be thought of as a size, yes.
Equal amounts.
Equal amounts, I like it. So what you just said is interesting. So has everybody ever heard of, like, if you do a scale model of something? For some reason I'm thinking about that scene from Back to the Future where he did a scale model of the whole town in the Old West. Anyway, if you've never seen the movie, you should. Scale model, what the hell does that mean? If I make a scale model of something, what am I doing?
Is it a smaller or larger version of what you actually want to make?
Yeah, normally smaller, but it could be larger, sure, especially if you want to talk about an atom, you want to build a scale model of the atom, we'll scale it up. Very often we scale things down. So I could tell you what the scaling is. So if I did a 1 to 4 scale, for example, what do you think that might mean? If I've got a city and I want to make a scale model, what would a 1 to 4 scale mean?
4 times smaller?
Yeah, so 1 to 4 would mean, like, this is not even the best. Let's do 1 to 40. That makes it a little okay. 1 to 4 could mean for every 1 foot in the model, it translates to 40 feet in real life. 1 to 40. I went ahead and made it 40. 1 to 4 is not. It's still kind of a little bit big. Okay. You guys semi with me? And you all know about scaling things down. You've all sort of worked with that kind of thing before. I like the idea that you can scale things up, totally. Okay. So that's another place where ratios come into play. What if I knew that in real life, in this town, I made a scale model out of this town because, you know, I just have so much free time. I made a scale model. In real life, I know that this one building is 120 feet tall. So how tall is it going to be in my model? Model. How tall will it be in my model? Real life, it's 120 feet tall. How tall will it be in my model? Well, let's see. All right. Everything in the model has to be 1 to 40. You guys agree with me? Everything in the model, for every 40 feet in real life, it's got to be 1 foot in the model. That's got to be true, period. So if in real life something is 120 feet, where should that go in the ratio? Where should it go, top and bottom? What if the minute I 1 over 40, what if I designated the top to mean? Where is this 1 foot? Where is it? Is it in real life or is it in the model? Model. So top is model, bottom is real life. Okay. If you were wondering what real life was, no, I can't talk. It's like my whole job. Shit. So then I would put 120 here, and up here I just put X. You guys, does this feel familiar? Have you guys done this kind of problem? I think we've looked at it in here at one point or another. How would you solve, in fact, yes, this is exactly, when I did fractions, I said cross multiplication, there's only one place you could do it, and guess what? It's right there. You don't even have to cross multiply here. Somebody see a shortcut? Do you really have to go through all the algebra? Is there a shortcut here? So you may see there's a shortcut. How do you make 40 become 120? So what do you do here? So what's x? 3. So if something is 120 feet tall in real life, in my model, it's going to be 3 feet tall. I like it, so then I can walk around. Oh, okay. Not too bad, right? I mean, you guys are all used to this. In fact, you do this all the damn time. What if your car gets... Somebody tell me what... You know what mileage your car gets? My poor little car gets like 21 miles to the gallon. 29? There you go. Now we're talking, right? So let's say I get 29 miles per gallon. What the shit does that mean, by the way? What's a slightly better way to write that? What's the per mean, of course? What's per mean in this case? For every, I like it, right? So 29 miles for every 1 gallon. People, it's kind of funny, but people do seem to forget that or to not know what it means. Miles per gallon just feels like it's one thing. No, it's per. It's a ratio of things, right? So what if I needed to go 187 miles? How many gallons of gas do I need to do that? If I'm, for some reason, I'm driving your car. Come back here. Yeah. How do I set up now? How do I set up a proportion? This is what this is. A proportion is just an equality between two ratios, right? And real quick, you see this all the time in cooking. Does anybody ever bake anything, cook anything? If it takes 3 eggs to make enough for 20 people, how many you need for 40 people? 6 eggs, right? That's a proportion. It's a very simple proportion. Okay, I like it. So what do I set up over here? What did I say, 187 miles? How many gallons of gas would it take to go 187 miles? How would you set that up? Yes, the top has been designated as miles. So you put 187 miles, and down here you put X, or your favorite letter. It doesn't have to be X. Poor little X dude gets used a lot. All right, take it a second to figure out what that is. I don't know. Let's see. It's not that. Yeah, it's about that. It's like 6.54. Sure. Okay. I got close. 6.54 roughly. Is that what it is?
4
or 5. Okay. Gallons. All right. And again, we do this. I don't know if you've ever been driving somewhere and you go, holy shit, why did I not notice I'm almost out of gas? And all right, how far till the next exit? Am I going to make it? I don't know if anybody's ever done that. You coast in and it sputters dead right in front of the thing. All right, so very basic usage of proportions. We do this all the time. Okay. By the way, just so you know, today is going to be a little bit of lecture and then a lot of group work, right? Just to let you know, how long is this guy going to talk today? My God. Okay, just make sure I didn't miss anybody. All right, so in general, when is this, how do I check to see if these are equal? What must I check to see if these two fractions are equal? Does anyone remember? Or how do I check to see if this symbol goes there or this symbol or this symbol? Do you guys, anybody remember? How do I check that? Nobody remembers.
Multiply, like, it would be D by A.
Yeah.
And
So what would make them equal is if AD and BC were okay. You guys remember that? There were some problems like that on this last test, if I remember correctly. I like it. So that's basically the idea behind a proportion. If they already told me that this is equal, then this must be true. Does that make sense? It works both ways. In mathematics, there's something called if and only if, which very often is reduced down to IFF. I see that. It was weird for me to write this, to be honest. IFF in my head means if and only if. That's what I see when I see that. If and only if means it goes both ways. So this equality holds if and only if this equality holds. What does that really mean? This is true if that is true, and this is true if that is true. It goes, so if and only if just means it goes both ways. Does it make sense? Okay. I like it. So, before I forgot, I wanted to show you the formal idea of cross multiplication. This is why it works, because if I know it's equal, that means that when I multiply like this, it still is equal. And then I can do stuff with that. Okay. Ground shape. Okay. Let me make sure I didn't forget anybody. All right, good. There's really not much more about ratios and proportions. You basically need to love them. Let me do one freakier problem with you. What if I had this? 7 is to 2/3 as, what you got, Jeff? 27 is to x. I don't know if you guys can tell, I was really nice to you in this problem. Now, on one level, I was evil, because I put a fraction into a fraction, right? And that's just something evil people do. Anyone see why I made this nicer than it could have been? Well, what are you going to do? How do you solve this? What do we use? Yes? Holy shit, yeah. So we got fraction equals fraction. It's given to me that it's equal. Therefore, I can just cross multiply the bottoms and with the tops. So I'll do this side. There we go. Then you have to do that side. So you can just write it 2/3 times 27, right? Now can you see why it was really nice? What happens? That's really nice. Yeah, 3 goes into 27. 9 times, you get 7x equals 18. So therefore, x is that shit. That's right, kids. Okay, nothing too incredible. Students will very obviously freak out when there's fractions inside fractions. I don't care what level of math you're at. If it's been a while since you saw them, you'll freak out. They're called complex fractions, which is a great name for them. I just call them fracception, but not too bad, especially when you're just cross multiplying. Bodacious. Okay. Ratio proportion, not a lot to them. Enjoy. The next really obvious step after that would be talking about percentages. Can somebody just, all right, so percentages, there's the symbol. Real quick thing about the symbol. A lot of people misinterpret where the symbol came from. And I know that you're all like, I love math, so math history is really my jam. Anybody have any idea where the symbol came from? Have you ever been told anything about the symbol? Have you ever thought for a minute where the shit that came from? Yeah.
It kind of looks like a fraction.
Okay, beautiful. So one kind of like misinterpretation is it does sort of look like something over something, which is basically what a percentage starts off as, right? If I had 11 people out of 30 that ate peas, then 11 divided by 30, that would lead to the percentage, something divided by something. Another way to look at it is it's the number 100 rearranged. Because what does percent mean? Per 100. So cents from centum. So we have 100 cents and $1. That's why we call them cents. Because we stole from Latin. Basically everything we have, we stole from Latin. And Latin's like, it's okay, I'm dead. So the real story, I'm not going to talk a lot about, but it's basically just It used to be percento, and people kind of started writing PC, and then they wrote the P sideways, and then it sort of became that. So just over time, it morphed as people wrote things really quickly, were got impatient, they kind of truncated shit. It just sort of morphed, and then that's what we got today. I don't know if that's more or less interesting, but it doesn't matter because that's the reality. Okay. Just in case, real quick, guys. One thing I love to do in classes is ask students something like, why is that a square root symbol? Did it have to be? Did it have to look like that? Hell, why the shit do we put a number there and that's an exponent? Did it have to be, right? I think I talked a little bit about this before, but just this idea of if you let students realize a lot of the stuff we use, a lot of the notation we use, we just made it up to capture these bigger ideas. It didn't have to be that way. That could freak some people out, but it could also go, oh, okay. I'm just trying to catch up with all this shit you guys thought up earlier. Okay. So percentages. Can anybody give me an idea about how percentages interact with decimals? What's the relationship? Like if I had a decimal, let's say this, how would that become a percentage?
Move the decimals to the right 2 times.
Yeah, why?
Because it's 700ths.
Beautiful, there it is. So this is actually, as a fraction, this is 7 out of 100. Percent means per 100. So you're literally just writing 7, and then you're putting a percent symbol to mean this divided by 100. Do you notice that means that the percentage number will always be bigger than the decimal number, right? You guys see what I mean? This has not been divided by 100 yet. This has. That seems very kind of minor, but it's actually pretty useful. So if I have a decimal, the shortcut is move the decimal back or forward 3 times. 3 times, Jeff. Twice, because of 100. So if I had something like, what about 1.29? What is that as a percentage? 129%. So anything bigger than 1 is more than 100%. I love it. 129%. Kick ass. What if I had a fraction 3/5? What percentage does that represent? Why was this so easy? Because it's out of 100, and that's exactly what the percentage symbol means. So what's the first thing I can do to this guy? Make him out of 100. So how do I do that? Times 20. 60 out of 100, so that would be, that's right, kids, 60%. Okay. So even though it's incorrect to say things like, look, the percentage symbol looks like the number 100, you could say that's a neat way to remember that that's what that means. It's 60 over 100. We just take the number 100, we mix it around, and there's the percentage symbol. I don't know. You could teach it that way if you want to. A little way to remember. Okay. So what if I had something like 3/8? Can you make that into 100 on the bottom easily? No. Could you make the bottom 100? Sure. You just have to take a minute, figure out what you multiply 8 by to make it 100. So what's another way to make this into a percent? One way would be to do what? How do I make this into a percent? I can't make the bottom 100 easily. So why don't I take an intermediate step? If I know something as a decimal, is it easy to make it a percent? Because then it's just moving the decimal place. So how do I make that into decimal? I just, sorry. You just do what? Long divide. Yes, you just long divide, right? 3/8 is a decimal. I don't know what it is yet because I haven't divided it yet, right? Does that sound exciting? You want to long divide a lot of numbers? So here's something else. What is 3/4? Every single person should know what 3/4 is as a percentage without doing any work. 75%, right? Are you guys at the point where you can tell me very quickly how 3/8 relates to 3/4? 3/8 is how much of 3/4? Can you do it? What do I multiply 3/4 by to make it 3/8? What do I multiply the bottom by to make it become 8? 2. So I multiply by 1/2, correct? Go with me. Isn't 3/8 1/2 of 3/4? So wouldn't the percentage be 1/2 of this percentage? What's 1/2 of 75? Quick way to do half of something that's not even is to do half of the next even number down. What's half of 74? Is that better? What's half of 74? 37. And then you put a 0.5 because half of the 1 is 0.5, right? So if you long divide this bad boy, you're going to get 0.375. Okay, all right. What about this? What about, how would you do 25% of 884? Why is that a specifically nice question that you don't even need a calculator for? Does anyone realize why? 3/4, you told me, was 75%. Can you go backwards? 25% is 1/4. By the way, what does of mean here? Good. So how do you do 1/4 of 884? That's 1/4 times 884. And then what happens really nice? What happens is really nice? 4 goes in even. What's 4 goes in 8? Twice. 4 goes in 8 twice. 4 goes in 4 once. Done. So, there are certain percentages that I can use mental math to do because they directly relate to fractions. What about, let me ask you guys something. What was 1/3? You guys remember what 1/3 was as a decimal? 0.3 repeating. Right? Okay. Make that into a percentage. What would happen? You give us a few more 3s. Make it into a percentage. What do? Don't forget. Well, how do you make that into a percentage? Bop, bop, right? So it'll be 33.3 repeating, correct? Isn't that 33 and 1/3? Isn't 0.3 repeating 1/3? So if I needed to do 33 1/3% of something, that's the same thing as dividing it by 3. You guys follow? Same thing as 25% of something is the same thing as dividing it by 4. Half of something, 50%, is the same thing as dividing it by 2, right? If a percentage is directly related to a fraction, that's a shortcut for doing of questions. Is that all right? Okay. There's also a nifty little trick here. I'm going to look at my notes here in a minute. I'm just kind of going off with shit. If I had to do something like, you can do it, Jeff. 87, let's do, you can do it, buddy. 68% of 25. Is 68% a nice percentage? No, damn it. Jeff, if you would have just put the damn percentage on 25, that would have been an easy problem, right? So real quick, I've seen this. So guys, I need to stop looking at Facebook. Just nothing good comes from Facebook. So every now and again, I'll see somebody presenting this like, holy shit, you guys will never, holy shit, look what can happen. And I'm like, oh my God, everybody should know this shit. Watch. What does 68% mean? Change it into a fraction for me. 68 divided by 100. And then of is times, right? Is everybody with me? Do you understand that I could that this is the exact same thing? As long as I'm divided by 100 somewhere, the math is going to work out, right? And isn't that 25% of 68? You guys see that? Do you guys see that? So, do you see the shortcut? Just move the damn percentage over there. Mathematically, why does it make sense? It's just moving to divide by 100 over. Who cares? Math doesn't give a shit. It's just like divide by 100 sometime. Do you guys follow what I'm saying? Okay. And then, of course, 25% is 68. What's that? It's 1/4 of 68. Does anybody know 1/4 is 64? People normally know that one maybe. 16, so 1/4 of 68 is 17. It's 4 more, right? Yes, okay. So if I have to do a problem, let me show you one other thing, and then I'll look at my notes. Probably forgotten some other stuff. If I have to do 1.5% of 90. That kind of sucks a little bit, but let me show you something kind of nifty. What is 1% of 90? You guys know? What's 1% of 100? 1. Is everybody with me? 1% of 100 is 1. So you're dividing 100 by 100, basically. What's 1% of 90? 0.9. I love it. 1% of 100 is 1. 1% of 90 is going to be a little smaller, 0.9. Does that answer this question? No. If 1% of 90 is 0.9, what's 0.5% of 90? You can do it. If 1% is 0.9, what's 0.5%? It's going to be half of that, right? What's half of 0.9? What's half of 0.90? 0.45. So what is 1.5% of 90? I add these together. That's 1.5%, right? So if I add those together, 1.35. So there's a nifty way to kind of like build the percentage you're trying to get to. So for another example, one that's not quite as freaky. If I wanted to do 22% of, you can do it, Jeff, 64. What's 10% of 64? 10% is an easy question because it goes with our number system. 10 over 100, 1/10. So to do 10% of something, you just divide it by 10. Do you guys see that? So what's 10% of 64? 6.4. So what's 20% of 64? Not half, because I doubled, so that'll be double that. What's that? 12.8. What's two, now let me see. Aren't I just missing 2% now? All right. So what's 2% of 64? Do you see how it's 1/10 of that? So it'll be 1/10 of this. You guys see what I'm doing? If I know 20% of something, I know 2% will be 1/10 of that. So I just moved the decimal back once. So what is 22% of 64? 14.08, I believe. Yeah. All right. Let me check. Let me see if I missed anybody. Probably. Oh, good. All right. No, really. What's unfortunate is I used to be asked people if they've been a waiter or a waitress, and then they kind of know how to do 15%. But nowadays, basically everywhere actually lists what the tip should be. I think that's good because people either didn't do the math correctly or they pretended like they didn't know how to do the math. I thought $2 would be okay. Isn't that 15% of 80? Yeah.
Can you kind of like break down the percentages? Because I don't get I didn't understand like the 2% part.
Oh, okay. If 20% is 12.8, 2% is 1/10 of that, divided by 10. So divide this by 10. And it's kind of a neat approach to percentages when you're supposed to do them by hand. You can't use a calculator. you build, I want to build 22. So I start at 10, that's easy. Then I double, great. And then I cut that by 1/10. And then I can combine, I build what I want. How do you do this in your calculator? What would you put in your calculator to do this? Good, you change that into an actual number, percentages. Now, ignoring the fact that we made up all numbers. We just made them up. They weren't laying in the ground. Made all that shit up. On top of that, percentages are definitely made up shit. We just made them up, totally. So what's the actual number? It's 0.22. Of means times 64. So you just shove that in the old calculator, and hopefully you get 14.08. You can double check me. All right, maybe it came out okay. I don't hear anybody yelling at me, so apparently it worked. Is that better? And again, there's nowhere in the book that's going to necessarily ask you to do this. I am just a weird math guy. I just like to give you a complete picture about whatever the hell we're talking about. So this kind of approach to percentages is awesome, right? But if you got a calculator, obviously you're going to use that. Okay. Let me say a phrase. We're sort of like in that direction now. Is over of. Have you guys ever heard that before? Is over of equals percent out of 100, right? So these are the kind of problems like if I said, what percent of 40 is 11? So a standard way students would do this is exactly what I just said. Is over of equals percentage out of 100, right? So what's the is number? Now here's why I don't like this. I'll show you a better way to do this. What's the is number? Do you see how people might think it's 40? Do you think how students, especially younger ones that don't know much, they're going to think maybe the 40 is the is? Because there, 40 is. 40 is the is. No, 40 isn't the is. So it'll be 11 out of 40 equals percentage out of 100. And then you just solve that, right? You guys semi with? Okay. There are other approaches. Here's one that, let me see, I'm going to put it up here. I'm curious how many of you guys have ever seen this. Okay, now watch. I had to look this back up because it's been a long time since I saw this, but I saw a student, I think it was a student I was helping, tutoring. They showed me this. I'd never seen it before. So here's the thing. What is it we don't know in this question? What do we not know in this question? Percentage. Cover it. What's it tell you to do? Is over of, right? You see what I mean? All right, so what about if I had, by the way, anybody got this answer? What would it be, Jeff? Can you do it? 5.5 times 5, 27.5, is that right? Yeah. Is it? Hey! Okay. So if I asked instead, what is 12% of 13? Now, which thing is it that we don't know? We don't know the is. So if I cover is, now one thing I forgot is you put a little times, but they're sitting next to each other, so you actually don't need it. If I cover the is, I'll do the percent times the of, right? You guys see what I'm saying? I am of two minds about this. Part of me thinks this is kind of cool, and I can see where students would kind of love this. Another part of me that I think is a little bigger than that first part does not like this because you don't really need it, right? I'm normally against adding something to math that you really don't need because automatically you just added more shit, right? But you guys can see that a student might gravitate towards this because it's nice. You just cover what you don't know and it tells you what to do, right? So whatever the hell that is, I almost don't care. What is that? Who is it? 1.56, okay. So then what if I ask, sure. Maybe not. Poor little dude. What, you can do it, buddy. 11% of what is 99? So now what is it that we don't know? We don't know the of, right? So if I cover that, what's this telling me to do? Yeah, take the is number divided by the percent, right? You guys all with me? Okay. Personally, so that would be 99 divided by 0.11, right? And what do you get? 900, yeah. And you can double check it, right? You can do 11% of 900, and you can see that it is 99. Here's the way I prefer to show this when I'm teaching, like, again, back in the day when I could teach math at 88. This directly translates into an equation. 11%, 0.11. What does of mean? Times what? So what in algebra? I don't know what the shit that is. I'm going to call it, holy crap, is. What do you think that is mathematically? Is equals. And how do I solve this? I divide by 0.11, which is exactly what that has me do, right? So that reinforces Solomon equations, that reinforces use of variables, right? You can see what I'm saying? Okay. Maybe. Okay. I think, yes. Yeah, there is that approach. Yeah, let's do this. Oh yeah. Last thing, I'll give you this group worksheet. If I had a hat, I want to buy a hat, and it's on sale, 15% off. Sale price is $17. What was the original price before the discount? What do you guys think you'd do? Yeah. No. Do you guys, okay. What did I take 15% of to get to 17? Do we know what that number is? Would I do 50% on 17? No. If I knew the hot hat cost 30 bucks, I'm talking snazzy, it's 30 bucks. This hat costs 30 bucks, right? How would I figure out how much it would cost after a 15% discount? What would I do? I would take, how do you figure out? So 30 bucks, 15% discount, how do I figure out how much it costs now? I would take 15% of 30, so 0.15 times 30, and then that amount I would subtract from 30, and that would give me the new number. That new number, I didn't do shit to it. It's the result of something I did shit to some other number to get to, right? So the most common mistake I see is I'll have a student do this. They'll take 15% of 17 and add it to 17. Let me let that sink in for a minute. Do you see the logic there? There is logic there. It's wrong, but I can see why they thought that would work. Let me say this again. They take 15% of 17 and they add it. What are they thinking? How did I get to 17? Didn't I take 15% of something and subtract it? So their brain is saying, let me just take 15% and add it. Why will that never get back up all the way to the original price? Sure, sometimes I have people just add 15 cents, which is hilarious. Right, but and again, I understand the logic, but it doesn't make sense.
It's 15% of another number.
Beautiful. 15% of 20 is very different. I gave the answer. We should. 15% of whatever it is very different from 50% of 17, right? So it used to be a bigger number. So I took 15% of big number to get the smaller number. If I had 15% of smaller, it was never going to get all the way back up. Does that make sense? Okay. So how the shit do I do this? Here's a cool thing about, if it's on sale for 15%, what percentage of the cost is still there? If I take 15% off, what percentage of the cost is still there? 85%. So there's 85% of the original cost is still there. That's the best way to do this kind of problem. It's a backwards problem, which is why algebra shines. Algebra's job is to help us when we don't know what we normally would know. We know the result, not the original. Algebra comes in and says, I got you. So then let's see if we do get the number I just gave away. What do you get when you do that? 20? Yeah, good job, Jeff. Okay. And to check it, 15% of 20 is 3. Take that away from 20, you get 17. Amazing shit. So, I'm really sorry, by the way. I totally forgot to put little, well, actually I did. I just didn't have time. So there's no little pictures on here. I'm just going to have to group you up a different way. There's a front and a back to this, just because I'm a math teacher. Anytime. Anytime. All right, so let's just do this. Why don't you guys? Oh man. All right, guys, let's go over this worksheet, and then we'll. Just gonna let my voice get deeper. We'll talk. We'll leave after we do this. All right, guys. So the very first problem is more exercise in reducing, right? So obviously the fraction you would write would be 81 over 135. If I was specific and I said write a fraction part to whole, if I said that, what would that mean? Yeah, so I'd have to really be more specific. This is just direct translation. Here's a ratio, make it directly to a fraction. And of course, remember this 8 plus 1 is 9, 1 plus 3 plus 5 is 9. So therefore 9 goes into both. That's one way to do this. When you divide both by 9, what do you get? 9 over 15. And then that goes to 3/5. I like it. You could divide by 27, that works also, right? But who cares if you get there in one step or two? So remember, those little tricks we learn about dividing by numbers to see what works, they come in so freaking handy. And that's why you should be upset if you think you were never taught those things. You should be a little upset. All right, so in a bag, obviously I was wanting some chocolate when I was making this. There's 15 Snickers, 13 Twix, 26 milligrams, 40 Hershey's. The ratio of Snickers to Twix is 15 to 13. Now, real quick, would a student freak out a little bit possibly about the fact that that's improper? What would you tell them? If somebody's like, wait a minute, that's bigger than 1, what would you tell them? If somebody said, I don't understand this, it's bigger than 1. Do you guys see what I'm saying? What would you say to them? Are you concerned about that? Why are you not concerned about this? It's not a true fraction. This is a what kind of part to part. Right? So that it could be any freaking thing. I don't know, whichever one is smaller, if I put it on the bottom, oh well, it's the way it is. So you would tell them if you did a part to whole, then the bottom would always have to be bigger, correct? Because then the top would just be a part of the bottom, right? Okay. And then Milky Ways to Hershey's Kisses.
26 over 40.
What did I say specifically? I said the ratio, so you could even write it like this. I didn't say a specific way. Even if it's written like this, you can reduce it. What does that go to?
13 to 20.
13 to 20. So again, if I don't say a specific way to represent it, you can represent a fraction, you can represent a colon dude, right? Okay. Now, I like the fact some of you guys have shortcuts for these, and I had a little discussion about the fact when you're teaching, and for yourself too, if there are shortcuts, and you actually say to yourself, I don't know why that works, you need to find out. When you're first teaching people something, you do not want to rely on any shortcuts. As they learn more and more, you start to go, oh, here's a shortcut, here's why it works. Now you can use the shortcut, right? You need to give them a strong foundation to build off of. But what way did you guys do this? What did somebody do? How do you do this? How do you do this? Cross multiply, okay, so 12 times 14, 168 equals 3x. Divided by 3, what do you get? 56, I like it. Kick ass. That was nice. I made it nice. I don't think I even tried to make it nice. Oh. What's another way, real quick? Did anybody see another way to do this?
3 times 4.
Yeah, 3 times 4 is 12. Therefore, 14 times 4 is the answer. 56. Kick ass. Will it always work? No, I just gave you a nice number here, right? What about this guy? It works the same way, it's just got some decimals in there. Notice there's a shortcut to cross multiplying here. Why would I multiply that up when if I multiply that up, x is by itself already, right? Do you guys see that? I don't have to multiply both of them up. If I just multiply that up, x is by itself already. So then I just do 1.3 times 3.4 divided by 2, and what do you guys get? 2.21? Neato. Alright, I like it. And then this is the one that we really, really love. I want to point something out. Well, if you do this directly, so you multiply this up, 1/3 x equals, and of course that's 3/4 of 8. Right, so you get 1/3 x equals 6, and then you multiply by 3 to get 18, right? I want to point out, does anyone know what 1/3 divided by 8 is?
2.6.
No, not decimal. I want to know exactly. 1/24.
Yeah.
Does anyone see that? 1 divided by 3, and then I divide it by 8. So it's like cutting it in thirds and then cutting it in eighths. Of course, that's cutting it in 24s, correct? And I can do the same thing on the other side. That would be 3/4x. Anyway, that doesn't really do a ton for you, but you can work with complex fractions more directly. It doesn't do anything for you, but just to point it out. And then you just blah, 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 keep going. Okay. What about Josephine? Typing away. What can you set up? I'm not sure how you guys did this. You could set up a proportion. You could actually kind of do it a few different ways.
33/45 equals x over 120.
Yeah, good. One thing to notice is the units aren't the same. So you gotta make sure everything's in seconds. So I don't know how many, so this is words over minutes equals words over minutes. I'm sorry, words over seconds equals words over seconds. So this would be 120. And then of course, after some multiplication and so forth, you should get 88, right? 88 words. By the way, just to make this point, you could do this. You could do it, Jeff. 33 words to x equals 45 seconds to 120 seconds. You have flexibility, and again, as long as you maintain the definition of your first ratio with the next ratio, you're golden. You guys see how that would lead to the same answer? You still get 45x and you still get 33 times 120, either way you do it. Okay, these guys, what's the quickest way to handle, well, probably the quickest way to do this is actually make it a decimal first, right? 3/5 is a decimal is what? 0.6. And I didn't feel like I needed to show you this, but just to show you this, if you write decimal, if you write the letter for decimal, the letter percent in alphabetical order, it'll actually show you which way to move the decimal. So if I'm in a decimal, I gotta move the decimal this way to make it a percent. If I'm in percent, I move the decimal this way to make it a decimal. Right? Okay. I made that up. There's not much to it, who cares? So I move the decimal, bam, bam, 60%. Sweet. 42% is what decimal? 0.42. And then either way you look at it, it comes out to be the same fraction, right? Just percentage is nice because it'll be 42 hundredths. I mean, that means per hundred. This guy kind of tripped some people out. All day freaking long you can have less than 1%, right? We want to have less than 1%. What's the occurrence of this crazy, horrible disease? We want it to be less than freaking 1%. That'd be awesome. Better than freaking 3% or whatever. So this does come out to be what percentage? Jump, jump.
9.
Yeah, just below 1%. And let me show you something. You can see here it's going to be tens, hundreds, thousands, 10 thousands, right? Can you see a student writing this as a fraction? Do you see, because percentage means over 100, correct? Don't have to move this over twice to make it a whole number? And then add 2 zeros and you get the same damn answer that way too, right? Okay. So it'll be 97 over 10,000. Same number of zeros as there are decimal places. Kick ass. Anything that's bigger than 100% is going to end up bigger than 1 as a decimal, right? So what does this become? Chop, chop, 8.13. And then I had a few people kind of worried about how to change this into a fraction, but it's no matter what the hell's going on, tenths, hundredths. Even better, what's this? 813 over 100, done, right? Either way you look at it, it's 815 over 100. I would also accept 8 and 13 hundredths. You can make it a mixed number. Okay. So generous of you, Jeff. I don't know why I put this here. It's basically the same problem as this, but 0.8 would be 80%. That's crazy, and it would be 8 tenths. I think I talked to some of you guys. I don't really care about reducing this. 5/8. You could long reduce. You can long divide that. What do you guys get when you long divide that? 625, and as a percentage, that would be 62.5. Okay, cool. All right. This one, I'm almost certain you guys just divided that in a calculator, but real quick, what's 3 over 20? That would be 15%, is that cool? So 3 out of 40 would be half of that, so that would be 7.5%. Okay. Or you're just doing the old calculator. I like it. This one I specifically said translate to an equation, and I really should have just said whatever way you like, but you guys should all know how to do some equations. So how would I translate this into an equation? Equation.
0.45 times.
Equation. What's the what? What's the what?
X equals 0.4.
Thank you. 45% of 100 is 45 by definition. So 45% of 200 should be twice 45, 90. Kimber, somebody showed me something. Oh yeah, they did half of 200 is 100, therefore 0.05 would be 10, 100 minus 10 is 90. So you can kind of do like we did, constructing what we need. This would be 72 is what percent of 135, so then of course you just divide. And you get something that looks like it probably comes out not too evil.
53, well, it's 0.53 repeating.
Oh, 3 repeating?
Yeah, just the 3 repeating, so, yeah.
Why does that make sense? Because 72 would be half of 144, so it should be a little more than half of 135. So your answer makes sense. And then finally, you got 2 is 5% of what? So when you divide by 0.05, what do you get? 40? Nice. Okay. Number 8 might trip you up if you try to make more out of it than it is. The tax is $1,600, which is, so $1,600 is 8% of, I don't know. So that's not a problem. Like the hat problem, that's just direct. So when you divide by 0.08, what do you guys get for the cost of the car? 20,000. Relatively cheap nowadays. And then finally, this one, I think I talked to every group about this one. When you have a discount, you subtract. So when you have a markup, yeah. So $2,002 represents 110% of what it was. So if I have a discount, I go down from 100. If I have a markup, I go up from 100. So then I just divide by 1.1. What do you guys get? 1820. Good year. Okay. Actually, probably bad. Well, let's use bad. What happened in 1820? All right, guys. Unfortunately, I had forgot about this. They have no videos of students doing anything with 7374. So we don't get to see our favorite peeps. But when we get to chapter 8, there'll be more of our favorite people to see what they're doing. But that's plenty for today. We'll leave, well, just a little early. Let me know if you have any questions. Otherwise, I will see you Thursday.